Okay, this session we're going to look at an easy truss ready for import into Karamba. Parametric truss, so we can change the truss length, the truss height. These are the main parameters that we'll be looking at. The number of bays and the pattern of the truss as well. Okay, that's a Ferndale truss. Obviously this is ready for import into Karamba or into some other external analysis software, but what we'll be concentrating on is the stick diagram, the stick model that we would need before we import that. Okay, so we'll be looking at these parameters. We'll just go over through some basics. So we'll start with creating a point at 0, 0, 0, and we'll just simply move that point and then draw a line from both points A to B. That creates our bottom chord. We'll move that bottom chord up to create our top chord and divide those chords to create the number of bays we need. So here we'll divide into 4 bays and that will give you 5 points. It's important to understand the data structure. So when we divide the chords, depending on how we do it, we'll get a data structure something like this, where you'll have 2 branches and each branch will have 5 items, 5 division points, which creates a 4 bays. So that will be a parameter. So the number of points will change, but it'll be branch 0, item 1, 0, 1, 2, 3, 4, and then branch 1, 0, 1, 2, 3, 4. Once we have a data structure in this format, we'll then use relative item, not to be confused with relative items, and use an offset mask to associate one point with an offset point. Okay, so you have an item A and an item B, or point A and a point B. The way that works is, for example, if item A is item 1, point 1 on branch 0, if the offset is +1, where +1 is a branch offset, so it goes from branch 0 to branch 1, and then the item offset is from item 1 to item 2, right? So it'll give you an offset like this. So we can use offset mask +1 minus +1 +1 to create diagonals like this. You know, if we use an offset mask of +1 +0, we can draw verticals, and using a -1 offset to go backwards, and we can even go sideways where we don't move a branch, we stay within the branch, but we just move from one item to another item. So +0 +1 will give you horizontals. Okay, so we'll end up with a pattern like this. The important thing about here is that the chord is not a single line, it's segmented into individual segments from point to point, and that's really important for Karamba analysis and for other softwares. Once we have all the bars and elements like this, we can then play with patterns to then create the truss pattern that we so desire. Okay. All right, let's start off. We'll start off with first point 0, 0, 0, and then we'll move that point along the x-axis and we'll put a force in here from, let's say, 2 meters to 20 meters to 20 meters, 0.00, to give some decimal places. Okay, so that goes from 2 Slider's not sliding. Here we go. Okay. So that's moving that point. Now we've created a point AB. I'll just make a copy of that point, and we'll do line AB from the origin point to the move point, and that creates our bottom chord. Okay, so very simply we've just created bottom chord. Switch everything off except for the chord that we want. Now what we'll do is we'll just move that chord up. This time we'll move this chord up into the Z axis, and this is the truss length. We'll just make a copy of this slider to make the truss depth in meters. Let me just pull that down here. Okay, so that's our truss. Top chord and bottom chord. Just put that into a line container. Just keep everything tidy. Top chord. That one is bottom chord. Add it to that group. Top chord. Switch everything off except for the two chords. Okay, what I'm going to do is I'm going to just connect these two chords using a merge. So I'm going to connect this data together. I'm going to use a merge command just because that helps with the order that it's in. So these are lines. So these are our chords. Okay. Let's just collect chords. And this just makes it easier to work with. Now it's one data stream. So what we'll do now is we'll divide these chords by a divide curve. By default it's 10, but let's go 2 to 20. I don't need to put any decimal places because this should be a whole number. Number of bays. Okay, so this is the division. What I'll do is I'll put that into a container. And that can go there. I'll collect all my parameters here. Keep everything nice and tidy. Okay, so this is us dividing the two chords by a number of bays. Now you can see that the data structure is 2 branches with n equals 12. Let's just bring that down a little bit. Okay, so this is dividing the two chords, and the output is of course your grid of points, point grid. Divide chord. Okay, so now we've got our point grid as shown in at the start of the presentation. We just use a relative item. Just note there's a difference, relative item and relative items. We want relative item. We'll take the point grid and we'll put it into T, which is the tree structure. Then we'll want offset. So let's just do a vertical post first. So that would need an offset of +1 for for the branches, but +0 for the items. So branches are in curly brackets, +1, and items are in round brackets, +0. You don't need a plus, but I find it useful for notation to understand what's going on. Okay, and then that will give you 2 points A and B, and then we can just do a line AB and join that up. Now you can see this is orange now. Orange is usually a warning or an error, and it actually hasn't collected any data. That's why the wires are orange. There's no data in A and there's no data in B, which means that the offset hasn't worked. The reason for that offset not working is that the format of the offset doesn't match the data structure of the tree. So if you look at the tree structure, it's 0 semicolon 0 n equals 6 and 0 semicolon 1 n equals 6. What this means is that there's 2 levels in the branches before you reach the items, whereas our offset mask only talks about a single level. So what we can do is we can add 2 levels here. We could, for example, add 0 colon +1, and now you can see that has worked. But I prefer to just simplify the tree structure. Actually, I might simplify the point grids. So you can see the point grids has 2 levels, 0 semicolon 0 and 0 semicolon 1. So I'll simplify that. Then the point data going into the tree structure here matches the offset mask. Okay, so you can see it's just 0 and 1, just matching the structure here. So that's how we'll draw the vertical lines. Vertical posts. And then we can do the chords. So if I unpreview that, because these chords here, these are just 2 lines, 8.73 meters, but we need them segmented for Karamba. So we'll just change this mask. +0, +1, and then we'll do some diagonals. +1, +1. So these diagonals have gone backwards because I defined my top chord first, and then they're going forwards to the bottom chord. And then we'll do the diagonals in the other direction, simply by changing the offset mask to -1. Okay. That's pretty much it. Nice and easy. We'll just collect everything here. Call this posts. These are chords. You can see the wire is dashed because it's grouped information, branch information. It's got 5 segments top chord, 5 segments bottom chord, and we have diagonals backwards and diagonals forwards. Okay. We'll leave the opposing chords for the time being, and we'll work on the diagonals. So we'll take these diagonals, and we'll work on a pattern for them. We'll just do a dispatch pattern. Okay. So we'll feed the diagonals in, and there'll be a true-false pattern by default. So true will go to A, false will go to B, and then they'll just give us a 1 2 1 2 pattern. So you can see here that if I put another container in here, switch this one off, this just gives you the true, false, true, false, true, true, false, true, false, true, false, true, false, true, false. And then this one will give you the false pattern. Okay, so that gives you the ones in between. Now we can do the same with the other diagonal pattern. So these are the forward slashes. So I'll just change these as well. So this is true first, and this is true alternate second, but forwards. So this notation just helps me understand which container contains what, because now I can merge them. I can take this one and would be this one, and it creates one pattern. And this one with this one. Let's just do this one first because it's the first. And this will give us the upside down pattern. Okay, so that will give us diagonal pattern. I'm going to call this 1. Okay. So that's this pattern and this pattern. Okay. Now let's look at another pattern where we split. We'll have 1 2 3 1 2. So what we'll do is we'll split the list up, and we need to split it at halfway, which is just simply the number of bays that there are. So if I take this number of bays here and then I divide it by 2, x divided by 2, that will give me the halfway point for this. So this is A and B split into half now. A will then look like this, and B would look like this. Okay, so this will be A, and this is B. And my notation just follows what's happening on the screen. And we can do the same here. These are forward diagonals. And now we can just connect it. This one with this one, and this one with this one. Just tidy that up a bit. Just tidy up the notation. So this would be, and this would be the opposite. So this allows you to choose which pattern you would like. Different patterns will give you different performance, and you can just parametrically check all that. So that gives you the 4 patterns here. So we can start to collect these ready for Karamba input. So you can either choose this one, or this pattern, or this pattern. So we'll just do a simple stream filter. So I want the one that goes multiple inputs into one. So I'll have this go into 1. I'm purposely leaving 0 blank, as in if I have 0 diagonals, pattern 0, then I have a virindle. And I'll allocate this to 1, 2, 3, 4. And then we can just put a slider 0 to 4 to help select the truss pattern. That's an integer. So that's a truss pattern here. That goes into G the gate. Like that. And then we can bring this pattern all the way here to control all our parameters all at once. And we can have a lined container here. That is our diagonals. It's orange at the moment because the pattern here is set at 0, and so there's no information coming into here. So this is our Karamba inputs. Switch that off as well. I can bring this here. And these are parameters here. Just made that a different color. Okay, so you can change the pattern here. Change the number base. Change depth. Change length. One thing to note is I don't particularly like asymmetrical truss, so I'll just set the number bays slider type to even numbers, so that keeps everything nicely symmetrical. And you have your posts, your chords, and your diagonals ready for Karamba-ready inputs. Probably one more thing that you do need is just the support points. Now this could be the top chords or the bottom chords. Let's just take it from the bottom chord. So you have your bottom chord here, and we can simply just take the endpoints of your bottom chord. So you have to start end points. Points. Point. Just collect that. That's your support point. And we'll take that and collect it with the others. Here. We obviously already defined this 2 points already, because it's your origin and your move point as well. Switch that off. Okay. So you have your posts, your chords, your diagonals, and your support points. Something switched on here. Switch everything off. And there you go. So we'll do another session later where we'll show you how to input this into Karamba. And then we'll do another session where if you wanted to define multiple trusses at the same time, you have a bigger geometry where you're using multiple trusses. How can you define all the trusses all together at the same time using the single script? Okay, so we'll see you later. Thanks for watching.